Morning guys, Dean here at Builder Spa. Something we don't do often enough really is to show everyone around our manufacturing site in Hartlepool, and I thought today would be a good exercise to, or this week so to speak, might be a good idea just to show you guys around the facility, different processes, what we do, how we do it. Hopefully you find it engaging, exhilarating. So what I'm going to show you today is our shell reinforcement process. It's a new technique we've just adopted, so we've always typically used fiberglass, dirty vinyl ester and polyester resin, but we've moved away from that now. We've moved away to a new hybrid material using polyurethane. I'm just going to, can't get too close because I leave a mask on, but I'm just going to take you around to the robot and I'll just show you exactly what it does, how it works, materials in it, and the process involved to get there really. I'll just flip the camera around just 1 second. I do apologise if there's any background noise in it. It's quite loud in here at times. Okay, so what you see here, it's robotically applied polyurethane, so you can see how it's coming out the robot at the minute. It's a 2-part mix. One side of it is isocyanate, and the second side is your resin. Now this resin's been manufactured by chemical giant BASF. You might have heard of them, you might not have. And it's been specifically designed for the spa industry. So we've been keeping a close eye on this material for a number of years, as there's quite a few different adaptations of it. But this one is specifically designed for the parameters that we work within in the hot tub industry, which is exposure to UV, 40-degree temperature consistently. You know, it's not just a case of copying and pasting what was in the bathtub industry. So as soon as this technology came available, we've jumped on it, and it's great all around. I'm just going to flip it back around now. Go back around the other side. What it does is it takes the 2 parts, it mixes them, and it's applied at a high temperature, above 80 degrees. And this robot that we're using here, it's what's called a self-teaching robot. So what it does is, whereas the car industry or the automotive industry, they'll use ABB robots, and it'll be programmed using point-to-point programming. What this does is that type of robot is not really good for what we do. So we've got what's called a self-teaching robot. I wish it was self-teaching, but what we do is we get a trained operator to show the manufacturing process. And what it does is it records millions and millions of different positions. And as you can see there, you can almost see where the human would have been, and he's teaching the robot. And what that does, it allows us to get into areas where a point-to-point robot would never allow us to get into. The company that we use for this is a company called Leicester, based in Italy. And they've been great with us to come over and get us all installed and what have you. We do have a number of other robots in the factory as well, which I'll show you throughout the course of the week. Hopefully you find it interesting. So this process, the shell at the moment at the minute is a Zeus in Odyssey, which, as you know, we build to order. So this will be at its new forever home by the end of the week. One of the biggest and most important things with manufacturing this method is the heat. So the spa shell has to be preheated to a minimum of 55 degrees Celsius, and that's heated using a specifically designed convection heater to heat the surface of the temperature, so that when you apply the first layer of the polyurethane, it uses the adhesion layer, and that's what really prevents it from delaminating. It's what gives you the longevity of the spa shell. This manufacturing process and the material that we use, it's got a massive modulus of elasticity, which allows fantastic shrinkage and contraction during the seasons of the spa shell. So obviously, in Britain, the winters are quite cold, and it can be quite cold depending on the geographical location. And summers are quite mild. And also, we do export to other countries across Europe. So it's really important that this material that we took on allowed us to incorporate different working parameters, which is why we chose to work with BASF. As a robot spraying here, you can see that we've reinforced the spar shell in different locations, and they are just typically weaker points of the shell that's been reinforced with. So when the spar frame is eventually on, underneath each of the blocks will be an upward and vertical support, just to make sure that the spar shell doesn't move. But nonetheless, our spar shells are, and proudly, self-supporting. What this robot's going to do now, it's going to go around and it's going to coat it in about 8 layers. Each layer, believe it or not, is only 0.5 millimeters thick, roughly. So you can see how thin, it's almost like a mist, the application is on each layer. And once it's stuck, it's set within 3 minutes, which is quite impressive, because whereas typically we'd have to get fiberglass rollers, we'd have to roll all the air out. This material sets within 3 minutes, and we can advance it to the next stage, which is trimming the edges off and drilling the holes. I mean, it doesn't talk as much as a member. It's a lot more reliable, that's for sure. You can see the turntable turning around in line with the robot. That acts as the robot's 7th axis. So whereas you typically have a 6-axis robot, the turntable acts as its 7th axis, and it's got a digital encoder underneath the floor that links back into the robot's motherboard, and that tells it the exact degree that it's at. And this robot works within 2 millimeters of accuracy from when it's been programmed. That's pretty impressive. So whilst this one's in, we've got the next robot. We've got the next spar shell that's preheating now to 55 degrees. And I'll just take a moment and I'll just show you the exact surface temperature that's coming out at the moment. So you can see the surface temperature there is 57 degrees Celsius of the material that's being sprayed. And I just got the side that's spraying at the moment. You can see it's fairly consistent around the full shell. Obviously the fresher material is going to be hotter, but it does cool down within about 5 minutes, and it is rock solid. So just as another point, the isocyanate, that will be preheated to 85 degrees, and the polyol, which is the resin, which is the specifically designed material for the industry, that'll be preheated to about 65. The machine that we've got, it works on 1-to-1. We don't use any mineral fillers in the material at all. And what that does, mineral fillers, when they're in the material, they're used very typically in fiberglass, and also quite a few adaptations of this material across Europe are very, very big on mineral fillers. And what mineral fillers are, the damp and the weakness of the spar shell. I'll just turn the camera around. The damp and the weakness, the impact strength on testing is not as high, so you need to apply more of it. But the big benefit that mineral fillers has and offers is that it's cheaper. I don't believe that that's the way forward, which is why when we found out there was a material on the market that doesn't have many mineral fillers in it, we jumped at the solution to that. So you can see on the just show you the computer. This is there's two programs. So there's Zeus, which is the first layer, and then there's Zeus after the block. So what this is the first coat will The first coat will be obviously be without the wooden block, and then after there's another 8 layers that are added after the blocking system has been added. And this will just go on until it's finished, about 8 layers. So throughout the course of the week, what we'll do is we'll show you the thermoforming process, we'll show you the wood processing, we'll show you our electrical department, we'll show you just how we make hot tubs and why we're so proud of them and what the processes that we adopt, why we adopt them. There's a lot of good things that we do here, and to be honest with you, we don't probably shout loud enough about them. Yeah, if you've got any questions, give us a shout. Happy to answer any of your queries, and the team will be more than happy to assist. Other than that, have a good day, guys. Have a good week, and we'll catch up soon.